two positions that cannot be held simultaneously, but he does. There's no straight lines to acquire, but I can acquire one just by looking, right? That's the pain in the back of your head virus. Laugh it up.
Games. Virus, what's an angle and a sextant? Can it work with one of the parameters being a bent surface? Or is the sextant inoperable once you bring a bent surface to it? That's the question here. Is the sextant an angle measuring device as it's said to be, or is it not?
It is an angle measuring device that measures relative angles of the horizon and the celestial body. So yes, it measures angles.
Welcome to Flat Earth.
Well, yeah, thank you. Thank you, Nathan. Welcome to Flat Earth.
Welcome to the Flat Earth.
Okay, do you know what a vortex is? A vertex?
Yes.
Okay. You've got one of the lines that meets the vertex coming from the star's position to your position. Do you understand?
Okay.
The line that you're measuring the angle of, you're pointing your sextant at a star and measuring its angle. So you've got one line from your position to the star. That's one line, and it's meeting at a vertex. You understand?
Yep.
Yep. The other line, straight line, in order to achieve that, is running along the ground. You understand that, right?
Before the dip angle, no. But after the dip correction, maybe.
Okay.
But not before.
Okay. The guy's doing it on the ground, as in this example. He's basically on the water in his boat. On the water. There's no dip correction in this example whatsoever. He's in a tiny little sailboat. So he's not doing any dip correction. He's just measuring an angle. Now, I've got you to concede we've got a straight line to the star. What's the other line? Along the ground, right?
Straight line to the horizon.
Straight line to the horizon.
Straight line to the horizon.
So we've got a straight line from this position to the horizon. Well, in your globe world, that's a bent line, not a straight one. So welcome to Flat Earth. It's measuring a straight line to the horizon. You don't have that on a globe.
Yeah,
sorry, I'm making my conclusion.
Yes, you do.
I'm making my conclusion.
Okay. Not bad. Go ahead.
Yeah, you can detect the conclusion coming. That's why you started interrupting it. So we've got a vertex. We've got two straight lines. And you've just conceded one of them is a straight line out to the horizon. You don't have that on a globe, virus. Period.
Yes, you do.
No, you do not. Stop. Don't tell me that you've got... Stop. Do you understand that you have atmosphere on the globe?
Yep.
Then you never, ever, ever have a straight line to anything. Do you understand?
No, it's called your eyesight.
Sorry, it's called standard refraction. It's light bending as a standard through sphere-shaped air. Are you denying standard refraction on a globe?
No, are you?
Well, then you've got standard refraction on a globe. So you have never, ever got this scenario with a straight line that you describe out to the horizon. You don't have that on a globe. Period.
Okay.
Okay. That's the end of the argument for a globe. You require a straight line. You do have one and it works. Ergo. Not bent, as it must be and always is in your fantasy world of being on a sphere. No straight lines ever. This requires them. Along the ground, straight and flat, towards the horizon, as you've conceded. Welcome to Flat Earth. You don't have this straight line on your globe. Period.
We do. It's called looking at it. When you
looking at it through sphere-shaped air will bend the light at a standard rate of atmospheric refraction, otherwise known as terrestrial refraction, otherwise known as standard refraction, through sphere-shaped air occurring always. You don't have this straight line. Looking at it, what do you mean looking at it? That's not going to give you a straight line on a globe.
It does give you a straight line.
No, it doesn't. You've just hand-waved my description of air being sphere-shaped on a globe and having a standard rate of the light bending always.
That affects what you see, but it doesn't
Yes, so we can't see a straight line then.
affect anything straight.
So you can't see a straight line then. You can't do this on a globe then. Yeah, it affects what you can see, so you can't get a straight line. You don't have one.
You still have a straight line.
No, you don't. Not on a globe. Don't just tell me that you have. You haven't.
I'm telling you, you do.
Don't just tell me. I've debunked it based on the rhetoric of a sphere with sphere-shaped air, an atmosphere, and light bending around it always. Tough luck. You don't have a straight line. End of argument for you. Don't just tell me that you can get one by looking at it, when looking at it involves the light bending on your globe world.
Why don't you look at how eyes look at stuff and not?
On a sphere, they look through sphere-shaped air, so we haven't got a straight line. So don't describe how optics work when on your globe you always have light bending.
And you still have a straight line by looking.
Refraction comes back to bite you guys, doesn't it?
Yeah, sorry.
Terrible,
Sphere-shaped
isn't it?
air,
No, it
standard
doesn't.
refraction. You don't have a
No, it
straight
doesn't.
line. Why are you chanting through me that you do and you can just look at it to get one? No, you can't.
Yes, you can.
Don't just chant that you can when I've described why you can't. I describe how on a globe you've got light moving through sphere-shaped air always. That is how you see on your fantasy sphere world. That's a fact. Now, unless you can contest it, don't just hand wave it again or I'm going to kick you out. Do you have a rebuttal to what I've just said in terms of the globe claiming you've got sphere-shaped air and light always bending through it at a standard rate based on R? That's a fact.
Okay, when light bends at a distance,
I don't give a shit. It means you haven't got a straight line if you're now going to describe how light bends. Right? That's not you acquiring a straight line on a globe because you don't have one.
yeah, we do. It's called eyesight, man.
So eyesight gives you straight lines. So therefore black swan. Horizon, we've got a straight line to it. Therefore, we haven't got a physical geometric sphere edge horizon because if we've got a straight line to it, it's way beyond the geometric limitations of a sphere. So black swan, buddy. Straight line to it, well, black swan.
Yeah, the black swan
Yeah, but black swan.
out, and you still
Black swan.
see the horizon. Yeah, black swan. Yeah, you.
Yeah. So if you're saying we've got a straight line to the horizon, it's beyond the geometric limitations that straight line could be.
Oh, the horizon is still straight in front of you.
No. According to you, it's refracted always. That's what the globe states. You have a bent line always, never a straight one, always refracted. Don't you forget how you tell us that it's okay that the horizon's not where it would be with a straight line to it. It's refracted, right? Yeah, that's because it's always refracted on a globe. You've never got a straight line ever.
Nathan, refracted or geometric is
coming
still
back to
straight in
bite
front
you.
of you.
Sorry, refracted or geometric? No, geometric only exists in the maths.
Okay, regardless.
Okay, it means you've never got a straight line. Your okay is no geometric, no straight line. Back to the original argument. So we're drawing a straight line with a sextant to the horizon. That's right. Welcome to Flat Earth. All your lines are bent.
The argument right now is if the horizon is straight in front of you, if you can get a straight line to it.
Sorry, if the horizon is straight in front of you on a globe, it's got a bent line to it. That's the argument. You just ignore it.
Those bent lines are still.
So you haven't got a straight one then if you're going to go out describing the bent ones? Yeah, you need a straight one. You haven't got one.
Yeah, and it's called.
Yeah, so that's the end of your argument. We need a straight line for this tool to work. It works on the principle that the ground is straight and flat to achieve 90-degree angle to the star and its GP below it. That's how it works. It's as simple as that. Well, you say, well, no, it can have a curved line. No, it can't. That's not how the tool works. It needs a straight line, as you described when you defined it. So if it needs a straight line, and all your globe lines are bent, you have no straight line for this tool.
If the horizon is straight in front of you.
It's not on a globe. How many times? You're just going to keep telling me if it's straight in front of you? What if it's not refracted like you all told us? You all told us it was refracted.
I said it doesn't.
No, dumb shit. You all told us it was refracted, right?
It doesn't matter.
Sorry, bendy crane refraction doesn't matter now. Suddenly bendy crane refraction's irrelevant. You've all told us it's refracted. Now you need a straight line to it. Suddenly that's a problem, right? Oh, the horizon's refracted. Don't you know what refraction is? Yeah, we do. You have it always occurring, always bent lines, never a straight one. Now you need a straight one. Suddenly we should forget about the refraction that you all told us. The horizon's refracted though, isn't it?
Refraction. I'm not saying that. I'm not saying.
You're not saying it. Yeah, you are. You just don't want to be now. It's bit you in the ass because you need a straight line suddenly. Yeah, for this tool to work, you need a straight line. You've described it as working with a straight line to the horizon in your own words. But you haven't got one on a globe. It's refracted, right? Like you thought that was somehow going to get around the black swan. Yeah, that means it's not geometric, no straight line to it then. Same thing applies here. So if it's refracted, which it is on a globe, it's standard, then you don't have a straight line anymore.
Okay. It doesn't matter if it's a straight line. If I throw.
Oh, it doesn't? So when you describe this tool and how it worked with a straight line, that doesn't matter. It doesn't matter the tool uses a straight line because you haven't got one. So suddenly the fact this tool needs and uses straight lines doesn't matter. It just debunks your globe belief.
No, let me.
Yeah, you described how it needed a straight line. I got you to talk me through it with a vertex and the straight line that meets that vertex at 90 degrees to the star. Then you went on to tell us how it doesn't matter that it needs straight lines because you haven't got one on a globe. Yeah, we know. Your globe's absolutely decimated and hasn't got any straight lines to give you.
Okay, if I throw a
You
ball
thought you
into
were
the air
going
that takes
somewhere.
a curved path, my eyesight to this ball will always remain straight to this ball.
I'm afraid not. The horizon's apparently refracted, and that's what this tool's using. You all told us how the horizon was refracted. That was your response to the black swan. Do you not remember your response to the black swan? To tell us it's refracted? Yeah, we know it's standard practice to refract stuff through sphere-shaped air. Standard, mate, standard.
It's fine.
Standard refraction.
Even in the,
Yeah. The horizon's not got a straight line for you. You're going to keep ignoring this indefinitely.
No, I'm not. Even when the black swan photo, when you're looking at the horizon, it's still a straight line to the horizon.
No, it's not. You've told us how it's refracted, you stupid mong.
Yeah, you're being too easy on him. It's not standard, it's extreme, remember? Refraction.
Either way, as a standard on a globe, there's refraction because there's always sphere-shaped air. Remember when they told us, we don't ever get to suck the air off the Earth to see the geometric horizon? It's always got atmosphere. Right? Remember that, Virus? Hello?
Ooh. There's nothing wrong with that. You're still looking straight at the horizon with your eyes.
No, not unless you
Regardless of
suck off all the atmosphere, my friend. Not looking straight at the horizon with your eyeballs on a globe. Not unless you suck off all the atmosphere. Why would we expect to see a straight line to it? We've always got atmosphere on a globe. So you've never, ever got a straight line to acquire as required by this tool. You don't have a straight line for your sextant. You don't have a straight line to the horizon. Hello, audience members on the anti-flat earth side. Hi! What's that you say? It's refracted? Look at how bent the cranes are. Well, that's a big problem when you need a straight line now, isn't it? Oh, yeah. Doesn't matter, though, does it, Virus? Doesn't matter that it needs a straight line, right?
All right, so if I'm looking down at this cigarette in front of me, is my eyesight going straight to it? Am I making a straight line?
No, not on a globe. Let me lay it out for you while you look down at your cigarettes. With your sphere fantasy. No, Virus. You're looking through atmosphere when you look at those cigarettes. So no, it's not where you thought it was. It's subject to atmospheric refraction on a globe. So in your stupid world of living on a sphere, literally nothing is where you think it is. It's all subject to refraction always. Hence you can't get a straight line to this horizon. So when you detailed how this tool works, getting a straight line just because you can see it, you can just see that it's straight and flat, right? Welcome to Flat Earth.
Doesn't Craig Fight the Flat Earth have a problem seeing his hand?
You see how your globe model just made your example, which should be really simple. It just crushed it. It just made it
Okay.
seem really silly.
Okay, y'all
Because
misunderstanding. I'm sorry,
nothing is
Chocolate,
where it's
but
supposed
y'all
to be. You get that,
misunderstanding
right?
of the globe
he's
is what's
arguing our
making this
way.
very funny.
You get that?
Sorry, we
You get
misunderstand the
that you
globe.
got-
No, we don't. We understand that it's subject to refraction always because of atmosphere, sphere-shaped air, and it's the rebuttal you give us to the black swan. It's refracted. And you tell us that further to that, we wouldn't expect to see the geometric horizon unless you sucked out all the atmosphere into the sky vacuum. Ironically, the very thing that would happen if we had one. But there we go, that's a different story. Ultimately speaking, we can never acquire a straight line to it ever, according to your religious faith, in sphere-shaped air, and light always bending through it. That's a fact. Now, you haven't refuted that, you've just told me I can look at the horizon. Yeah, and if you look at the horizon and assume you've got a straight line to it, then you've got a straight line to the horizon. That would be a flat Earth that you're describing. Then we ask you to describe how that's acquirable given that your globe always has bent lines, and the answer is you can't. Hence, this tool debunks the globe and proves Earth is flat.
Hey, Nathan, do you think that refraction changes direction of your looking? No,
On a globe it does, yeah. 7 over
That's what
6
you
of
guys
the
do.
radius value in standard format is precisely what it does on a globe if you believe you're on a globe. Yeah, that's right. It's standard.
so
How are you?
refraction.
This is what
are
you
you
guys have
saying
been
that,
telling us for years. Why are you laughing,
Yeah.
Virus? You
Chocolate.
clowns have been
Yeah,
telling us this
I-
shit for
I spent-
years, bro. Don't
Chocolate.
even try
I
that
spent-
shit.
I spent the
Chocolate.
weekend in Gym Pandas real quick, and they were, educating me, from Andrew Thomas Young's paper. They're saying, yeah, those light rays, they're curving to your eyeball, right?
Yeah, but
Yeah,
buddy.
they are.
Yeah.
They are.
Oh, they are? So they're curving to your eyeball from the horizon then. So you haven't got a straight line to acquire for this tool as you detailed it needing a straight line. You haven't got one then.
I don't care if the refraction wrapped
Oh,
around.
so the refraction that stops you getting a straight line you don't care about now? Yeah, you should. Because it absolutely annihilates your faith in a sphere. Don't care that you claim to always have light bending into your eyeball on a sphere. You should. Because this tool proves the contrary to that. Proves it's flat.
The back of my head hurts. No,
Good. Good. I'm glad you confessed to that. Hey, anti-flat earth fundies. The back of his head hurting, that's cognitive pain. Because he's told us how this tool uses a straight line to the horizon, right? You just look at it and it's straight. Or we just look at it with the black swan rebuttal in mind that it's always refracted, never a straight line to get. Now, this cognitive problem is called cognitive dissonance. Two positions that cannot be held simultaneously, but he does. There's no straight lines to acquire, but I can acquire one just by looking, right? That's the pain in the back of your head, Virus. Laugh it up.
it's funny because you think refraction changes the
Because that's
direction
a
of what you
nervous
look in.
laughter. That's why.
Sorry,
it's funny.
I think refraction changes the light of what we're looking. No, on a globe, when the globe claims standard refraction as a standard, they claim it changes where things that you think you're looking at with a straight line as you would are actually not in the position you think they are because of standard refraction, also known as terrestrial refraction, also known as atmospheric refraction. That's sphere-shaped air bending light into your eye. And you confess to it, right? Through your little chuckle. Yeah, light is bending into my eye. Yeah. Then you told us about the pain in the back of your head now, though, didn't you? Because the pain in the back of your head is what's really going to get focused on. Because that cognitive pain about not having a straight line when you need one is a bit of a bummer if you've got a globe belief.